Alright, here we have 7-5.5, mixed review number 2. So, problem number 6 says quadrilateral ABCD is dilated about the origin by a factor of 3 and then rotated 270 degrees clockwise. Find the coordinates of the image. Okay, so we really have a couple of things going on here. Let's say this. I'm going to go ahead and tackle letter A, and then if letter A double prime is not the correct answer, then it will be up to you to repeat these steps for B, C, and D to find B double prime, C double prime, or D double prime. Okay, so let's go ahead and talk about answer choice A. We know that A is at 4, 3. And of course, every point is made up of an X and a Y. Alright, and by the way, this is how I would, I personally would typically tackle these. Okay, when you dilate something about the origin by a factor of 3, what you're really saying is that we have 3 times x, comma, 3 times y. Remember, dilating about the origin is easy. You just multiply the numbers by the scale factor, which means that we have 3 times our original value of 4 and 3 times our original value of 3. So let's just say, you know what, here's our 4, our original x, here's our 3, our original y, and what do we wind up getting? We wind up getting this. We wind up getting 3 times 4, which is 12, comma, 3 times 3, which is 9. Now, by the way, that was for a prime. Okay, well, how about a double prime? It then says 270 degrees counterclockwise. So let's think about this. If this was quadrant 1, and we went 270 counterclockwise, we're going 1 quadrant, 2 quadrant, 3 quadrants, rotating to the left, which really means we actually wind up rotating 1 quadrant to the right. That implies that we flip our x and our y, and since we're actually technically only going 1 quadrant to the right, we'll change the sign of the 1 on the right. Okay, which now tells us that we can say 12, 9, and we can flip it to become 9, 12, and this one on the right goes from being a positive 12 to being a negative 12. And there is our A double prime. Alright, you can follow those same exact steps with B, C, and D to find those final answers. Alright, let's move on to problem number 7. Okay, problem 7, find the volume of the triangular prism after it has been dilated by a factor of 5. Okay, so what's our rule for dilations? We know that our V new, or our new volume, is the original volume times a scale factor raised to the power of 3. And this is, of course, for when we're dilating, or when we're dilating volume, because we're changing 3 dimensions. Okay, so another way to say this is V new is equal to the original volume times our scale factor is 5 to the power of 3. Okay, easy enough. And so we really just need to find this volume. Well, remember, we see this triangle right here, and we see this triangle twice. Whatever polygon you see twice is, in fact, the base. So, for us to find our original volume, we'll have to do the area of the base times the height. However, in this case, the area of the base is 1/2 the base of the triangle times the height of the triangle times the height of the prism. Okay? So, you must figure out which numbers to plug in there, and then you can plug it into that formula, and you'll have your correct answer. Moving on. Okay, number 8 says this. What is the vertical cross-section of a hexagonal pyramid? So let's just kind of do this. Let's say, you know what? Here is the front half of a hexagonal pyramid. And then for the back half, we'll just use kind of dotted lines. Okay. And we'll put some point right up here. And for the back half, of course, we have to use dotted lines. However, then we can use solid lines for anything up front. So when you look at this, the question is basically asking, well, what if we were to cut this thing vertically straight down the middle? And I want you to ask yourself, like we're cutting it straight down the middle with some sort of plane. What kind of shape would you see if you were to crack this open? And I'm going to leave this up to you to visually think about this. It has like a very fine point at the end, and then it widens down to the base at the bottom. So if you were to cut it down, what shape would you see? And I'll give you 4 different options. We could see a circle, potentially. We could see a hexagon. We could see a triangle, or we could see a rectangle. What do you think you would see? All right, moving on. Okay, for number 9, it says find the perimeter of the hexagon below. So remember, to find out what this, to find out what this right here is equal to, we'll have to use the formula n minus 2 times 180. Now, of course, this has 1, 2, 3, 4, 5, 6 sides. So we'll do 6 minus 2 times 180. 6 minus 2 is 4 times 180, and 4 times 180 is 720. Now notice that there are 6 angles in total that are all the same because this is a regular hexagon, and so we'll have to do 720 divided by 6, which is 120. If we take 5x plus 3, set it equal to 120, we can find out what x is. Notice though, we need the perimeter. So for the perimeter, each side is a length of 2x, so our perimeter will be 2x times 6, or our perimeter will be 2 times 6, which is 12x. Whatever you find for x must then be plugged into 12x, and then you will have your final answer. All right, let's go on to problem number 10. Okay, 10. A man needs to wrap a package for Christmas with dimensions shown below. What is the minimum amount of wrapping paper he will need to cover the present? Well, think about this. If you're wrapping up the present, are you filling up the inside of the present, or are you covering the outside? And of course, in this case, we're covering up the outside. So we are trying to find the surface area of a rectangular prism, and so our surface area formula will be the perimeter of the base times the height plus 2 times the area of the base. And I would encourage you to use this as your base, and that's as much help as I'm going to give you. You can do the rest on your own. Alright guys, I'll see y'all in our next video.